I think the biggest discoveries in the last couple of decades with respect to navigation is the role of the hippocampus and related neuronal structures, like the retrosplenial cortex. And what we've learned is that there's changes in neuroplasticity in these structures as animals or people learn to navigate around in their environments. And what this relies on is increased synaptic communication between sets of neurons. That's where the plasticity occurs. The way in which the brain changes with experience, neuroplasticity, is through a number of mechanisms, but the primary mechanism would be changes in the way neurons communicate with each other across synapses. And there are a variety of mechanisms that work at the synaptic level, and one of them would be to increase the efficacy of communication. So a neuron A releases neurotransmitter, which is received by neuron B, and if neuron B's reaction to that neurotransmitter is increased, then that's an example of synaptic plasticity. With respect to navigation, we believe that synaptic plasticity forms the basis of learning to move around in an environment. We've been working in an environment that has really shaped our species. And what we're doing recently is we're changing the environment in which we live. And we've invented GPSs, for instance. And so the brain that was designed, if you like, by natural selection to move us around in the environment and to create these cognitive maps, in the modern context isn't being used the same way it used to be. And so I think a lot of our cognitive abilities have actually atrophied because of technology like GPSs. Well, my colleague, Giuseppe Aria, has found that there is at least 120 people, and of course there's going to be more than that, that show DTD. And these individuals don't have any other cognitive impairment but get lost. They just don't seem to form a cognitive map. They can't navigate around in an environment, and yet their other cognitive abilities are intact. Attention is important to being able to form a cognitive map. Recognizing landforms is important in forming a cognitive map. If you can't tell one house from another or a house from a church from a store, you're going to have problems forming a cognitive map. But the people with DTD have these abilities. They have normal attention. They have the ability to recognize the differences between a church and a store and a house. And that's not the basis of their impairment. It's that they can't form the relationship between those things in their mind.